Hi everyone. Okay, we want to take a quick look at this question right here. It doesn't end particularly pretty, so just be prepared for that. But it does give us an example of a question where the restrictions are kind of interesting here. Okay, so first of all, when determining the restrictions, and we will get to solving it in just a moment here, but in determining the restrictions, typically what I would do here, what I would encourage people to do is isolate the radical. Okay, isolate the radical. Now, the reason for that is because the restrictions that go with a radical equation are twofold here. First of all, we know that we're not allowed to take the square root of a negative, at least not yet. Okay, we'll let that happen at university. But so here, I know that whatever's underneath that radical symbol must be positive. So the restriction here, okay, now you can take the square root of 0. Please remember to include the 0 there. That 3x minus 5 has got to be greater than or equal to 0. Well, that means 3x has got to be greater than or equal to 5, which means x has got to be greater than or equal to 5/3. And that is correct, okay? However, the other restriction here is that a radical will only produce a positive number or a 0 here. So we have to consider the range of the radical function as well. Okay, the domain is x is greater than or equal to 0, but the range is also y is greater than or equal to 0, which means what it's equal to, x minus 7, must also be greater than or equal to 0. And what this means right now is that x has got to be greater than or equal to 7. Now, in this case right here, if these are both true, then the overall restriction must be x is greater than or equal to 7. See, it's very easy to get the wrong answer here by doing the right step, just not doing enough of it. Now, when we solve this, okay, we're going to start from this state right here where we isolated the radical. Now what we're going to do is we're going to square both sides of the equation. Okay, and again, we can do that as long as we do it to both sides of the equation. We're doing that to get rid of the radical. And that's going to give us 3x minus 5 on the left-hand side. Now, please remember that you're squaring a binomial here. Squaring a binomial should not produce a binomial. It should produce a trinomial. And in fact, this becomes x squared minus 14x plus 49. If you're not sure where the negative 14x is coming from, FOIL. You gotta FOIL it. Please, FOIL. Anyway, back to this. So we got our quadratic equation here. Now we're going to get these things over. Okay, x squared minus 17x, bring that over, plus 54. Now, the bad news is that won't factor. I'll just let you know right off the top here, that's not going to factor. So that means we have to use the quadratic formula to solve that. But the quadratic formula is not so bad. Okay. I know some people don't like it, but you know what? It's pretty easy just to plug in those numbers, and you are given the formula here. Now, the nice thing is at this point here is it doesn't really simplify, so you're going to hit the end right away here. So at this point here, it's either 17 plus root 73 over 2 or 17 minus root 73 over 2. Now, this means that it's either 12.8 or 4.2. Now, our restriction is, now if we just looked at this right here, x is greater than 5/3, well, both of those look like they work. But the truth is, the restriction is x is greater than or equal to 7, and the reality is if you plug these both in, 12.8 works, 4.2 doesn't. Okay? So you needed to have both parts of that restriction in order to see which one of these roots is ultimately acceptable. This is a very good question for that, even though it didn't solve nicely at the end there.